Thank you so much for coming today. I'm Jeff Needham. I'm on the Industry Solutions team. And with me,
I'm Luca. I'm also with the Industry Solutions team, and I work with Jeff developing solutions for insurance.
yep, and we're here to talk about the Converged AI and Application Data Store. Convergence meaning we're obviously building applications, we're working with AI, and what does the data architecture look like when those two things converge? So, before we can bring AI into the app organization, before AI actually transforms our organization, where we want to be is level 4 and 5. So this is an AI maturity model. If you type in AI maturity model on Google, you'll see the Gartner AI maturity model. And it's got about 5 levels and sort of this end state where AI is part of our organizational DNA. It's transforming our processes and procedures. We all want to be at this end state, but we're probably at maybe level 1 and level 2. Maybe we haven't really moved out of a data science experimentation perspective yet. And where we really want to be is kind of this level 3. And this perspective that we're going to share with you this afternoon is all about bringing AI into applications, one of those core 3 themes that Sahir mentioned, of developer acceleration, AI inside of applications, and modernization. Luca and I are going to talk a lot about what it means to bring AI into applications. We're going to actually show you a couple of demos that we've built. So Luca, would you talk us through this slide?
Yeah. So as Jeff was mentioning, how do we apply AI where it makes sense? How do we incorporate it so it actually moves the needle for our organization? What we've seen is that many organizations start the other way around. They want to use AI, but they don't find the reason to use it. So that's why they get stuck at level 2. That's why they get stuck experimenting with it. And what we bring today is a framework that kind of brings order into this process, and we'll show you how to do this in a more strategic way and in a way that actually makes sense and can eventually move the needle for the companies, right? So we need to start with a reason. We need to start with the strategic objectives that actually drive our business. Once we have that, we can analyze the business workflows. We can dive deeper into each step. And then we see where we can find the hotspots, the places where data is hard to work with, where we have high data friction. And eventually, that's probably a good place to start looking to whether we can exploit AI opportunities, to where we can apply AI to eventually operationalize these applications and these workflows, and where we can reduce friction and where we can actually make a difference for our organization. So what we've done now is we've started from a problem and then we've applied the right tool, not the other way around.
Right. So Luca, I want to exploit AI, right? I don't want to just put a wrapper around ChatGPT for all the employees. And while that might be advantageous for some things, it probably isn't going to move the corporate needle in terms of reducing operational expenses or actually improving data processing workflows inside the insurance organization, right? So let's take a look at a couple of business objectives. Luca, do you want to share your story of making data easier to work with?
Yeah. So here we see a couple of business objectives: operational excellence and customer centricity. Nothing new here. We all know what that means. But
so where did those come from?
Right. So what we did here was an exercise. I was tasked by Jeff to analyzing business objective of a number of insurance companies. And how do you do that? You have to read through 100 pages of PDFs of annual reports. Very, very boring task. Thank you, Jeff, for that. And so what did I do? That was to get back to our framework. So that was my business objective. Very basic example, I know, but I think it kind of brings the point home. As I was saying, the objective was analyzing those reports. The workflow was reading them, right? Going through a number of annual reports, 200 pages long. So what did I do? I just applied AI. I loaded them into ChatGPT, and I asked ChatGPT, okay, so what are the most common themes? And this is an example. This is what we have extracted. This is what we have distilled out of those 200 pages PDF. So we have started from a clear business statement, clear business objectives. We've analyzed the workflow. We have seen where the friction was, in this case, going through lengthy PDF. And we have applied AI where it made sense.
So we kind of walk our own walk. So me being the old insurance guy, I asked my chief of staff here, whom I affectionately call that, by the way. So I asked Luca, please comb through all these annual reports. Find me the top 2 business objectives, right? And so the old guy, I start reading them. And Luca here is like, Jeff, we can just put these into ChatGPT and have them summarized. And so that's a great example, right, of making the data easier to work with. And this is sort of a small example of that previous slide. What does AI inside of business applications look like? We know that we want agentic workflows at some point, but right now we're in the world of business applications with user interfaces and business users. And AI can make data easier to work with. It's not going to radically transform the application yet, but it can make some of those data hotspots a little bit faster. So, Luca, can you walk me through this slide here in terms of our workflow?
Yeah. So starting from the business objectives, the 2 business objectives that we just seen, then we pick the claim process. Claim process is obviously ubiquitous. It's very common in insurance. That's why it's relevant for us. That's why it's relevant for this specific example.
Lots of data.
Lots of data, as we'll see in a second. And we've kind of broken down the workflow into these 4 steps. Obviously, there can be more, but we just wanted to make it easier. And we had a look at all the places where data is hard to work with. So first, we kind of had a look at where data was, what kind of data was involved in each and every step. So we might have images, we might have customer information file in different formats, we might have PDFs of rules and policies, and then all this process of adjudicating or litigating a claim must be documented. And that's usually a lengthy and manual process. So we figured that there might be something interesting here. There might be a place to apply AI, right?
So let's stop right there. Let's look at that workflow. So there's lots of complicated data. It's a complicated workflow. But if Luca and I are part of the organization and we understand the business workflow enough, and we can either at least have an understanding of where the data is hard to work with, what the data is, where it's hard to work with, and maybe we need to interview the business folks or the business SMEs. Maybe we need to go into the field and ask, how are you adjudicating claims? Tell me, where does it hurt right now? Where is data hard to work with? We can come up with a workflow like this, right?
Right.
So these are 2 steps. Walk us through, Luca, the other couple things that we need to kind of surface here and reveal.
Right. So once we have the workflow and the data, we've analyzed where it is hard to work with. Only then, as we've seen in our previous framework, we can apply AI. And we apply it where it makes sense. And now we don't start from the end. We don't start from applying AI. We start from the problem and we see where it makes sense. So at this point, we can match AI capabilities, NLP, image search capabilities to our business problem. We can actually see where it makes the most sense to use it. We have examples of interactions. We might be using a chatbot, which is interesting because we can finally use natural language processing. We can actually use natural language to ask questions to the data.
Entity extraction, text and image classification, right? There's a text summarization and generation, interactive chat, right? If we know that these 4 things at the top of that slide, Luca, right, are these things that come out of large language models, well, insurance is all about data processing. So we can kind of harness those 4 capabilities at the top and apply them to the workflow and the data that's hard to work with in that workflow, and potentially move the needle and transform a business application or a small part of a business app or a business workflow to make things easier to work with, to expedite the data processing in that workflow. Right?
And these are all things that were hard to, it was hard to do them before. Or sometimes some data was just impossible to use.
Or you have a guy like me who's just reading through PDFs manually, and a smarter guy like Luca who decides that I'm going to speed this up, I'm going to be a little bit more efficient about this. So we've got some demos, right? So Luca, walk us through the next handful of slides, because I think this is where it really kind of comes home.
So we get a couple of videos here. Can we play them?
I think you have to hit the clicker one.
Yes.
Yeah, there you go.
Perfect. So,
and it's quick. You're going to miss it.
We've built, so there will be 3 demos that we're going to show today. Don't worry, it's like we're going to go to the next slide and we're going to.
Yeah, that video ends. Yeah, so we'll go back to that screen that you just saw.
Yeah, so going back to the previous framework, the claim framework that we were analyzing.
So Luca's out in the field. He's driving around streets of Barcelona where he lives.
Yeah.
I'm the claim handler inside the insurance organization.
Yeah, I crash into another car and I'm like, crap, what do I do? So I send my pictures to Jeff. So Jeff receives them. What do you do?
Luca asks me, what do you ask me? You ask me, how much is this going to cost me?
Yeah, or how much are you going to give me back?
Well, you're going to have to give
That's
me,
what I'm going to ask.
You're going to have to give me a couple months on that one, Luca. I'm an insurance company. I don't move all that quickly, right? And then, oh, this damage photo, thank you. I'll file that away for later. But if I have the ability to now search by vectors, what can I do? I can upload that photo.
And what you get is something similar to what you get with Google Lens in this case, but with your own photos, right?
Yeah.
So you search by a photo. So your query is literally a photo, and what you get is you get all the similar pictures. And all of this is like kind of avoiding the painful task of going through different systems, different photos, doing that manually. And at the same time, the good thing about MongoDB is that we store vectors alongside existing fields.
Yeah.
So at a glance, the claim adjuster can see all the losses amount of other claims. Yeah. And that makes it much faster for an old man like Jeff, right?
Old man like me. I get the structured data that was already on the claim records, but I was able to now, hey, show me claims like this based upon just this damage photo. Now, if I'm an automotive insurer, a damaged windshield or a damaged headlight, I might get a lot of hits in the database, right? A lot of automobile accidents certainly are going to have a damaged windshield. As soon as somebody hits you, one of those windows is going to break. So let's walk through the next demo. How can retrieval augmented generation really kind of maybe augment and further refine, again, an old man like me, help me process that data a little bit more quickly and efficiently?
So we see a chatbot-like interface here. We're asking a question. And on the right, so remember, this is RAG. So we have 2 components, an LLM and the vector store, okay? Vector database. So we ask the question, and on the right, we see what the RAG architecture is retrieving and what is actually using to give context to the LLM. So 3 documents on the right, the 3 most relevant documents. And what is interesting is that we preserve semantic here, right? So we're asking for weather-related claims. And if you see, in the claim description, we have mentioned, at least in the first 2, of hailstorm and thunderstorm. Third one might not be relevant because there were just not enough relevant points in the data set. So we have indexed a text field as opposed to the previous demo where we indexed an image. So we see we just wanted to showcase different data formats that can be indexed through vector search and leveraged in a different workflow.
So I can traverse the unstructured data like the photos as well as the structured data that's already on the claim. And if I'm searching by damaged windshield, I get 1 million hits. This is far too many to work with. So let me kind of filter on some description category. Just description itself. Only show me the claims for adverse weather, for example. Mm-hmm. And now through retrieval augmented generation, I get a smaller set here. And if you notice, like on that image down in the bottom right there, the question that we asked for adverse weather-related claims, the adverse weather wasn't in the claim damage description itself, but there's water on the ground. So the vector search actually picked up, hey, this might be something related. Again, the human in the loop, I appreciate the fact that I got a smaller result set here. But I'm the human, and I'm going to make a decision. Are these relevant to me as the claim processor? Otherwise, I would have had to have read through the Jeff approach. I would have had to have opened up every claim and said, do I find images like this? Do I find images like this? And suddenly, within a couple of seconds, I can search through my claim history just based upon a damage photo.
And you don't need to be technical. You can ask this in natural language, right?
Yeah, right. And if for the developers in the house, if the business folks ask you, build me an application that allows you to do this, like we typically would build an API to do this. And if the business folks come along and ask a slightly different question, I have to build another API. And if the business folks come along and they want a slightly different feature with a slightly different question answered of the data, I build yet another API. And this is typical software delivery that we've known for like the last 20 years, right? And with retrieval augmented generation, I get one tech stack that I pretty much build once as a reference architecture, and I can ask a lot of different questions of that same tech stack without having to build another API and another API. So I get a little bit of an advantage here as a developer. So kind of walk me through the technical.
We have the PDF search demo first.
Correct.
Yeah. So just a little final comment in here. And we also have the LLM performing calculations here, which is not always accurate. In this case, it worked. But again, it's a helper. We cannot see the LLM as full replacement for a claim adjuster, but it's something that speeds up the process, right?
But it's where that hotspot is in the claim handling workflow. That one piece of data and that one part of that workflow, we're going to get to agentic AI systems. But right now, what can we do for our organizations? Start to transform existing business applications by making small sets of data easier to work with, particularly things like unstructured data. And speaking of unstructured data, so I'm the claim handler now. Luca lives in Barcelona. I know that there's a needle in a haystack here. I've got 10,000 different municipalities and regions around the world that I insure. Each one has their own guidelines. How do I find the right underwriting guideline quickly while Luca's on the phone with me?
So what we see here is an example of PDF search. So yet another data format. And here we see a further interesting aspect is the pre-filtering that can be added to the stages of the vector search. And here we filter by customer. This helps us filter through the different PDFs I just was mentioning.
Set the context, right? So.
So I can point vector search to the right document, right? I'm not sifting through each and every PDF, like finding not relevant information. In this case, I'm pointing to Ryan Tan, and I'm getting the PDF containing the risk management guidelines of Singapore, in this case.
Yep.
And I've previously uploaded those PDF to MongoDB. I've extracted the relevant entities, the relevant chunks. And now what I can do is I can index it and feed it back to the LLM. This is the answer that we see on the left. This is OpenAI, by the way. And
so this is much better than just simple Control F, right? We all have Control F on PDF, but if I have like 10,000 guidelines in PDF format, I'm the claim handler. How do I find the right one? Well, if I know the customer, if it's Luca and he lives in Barcelona, the large language model, the RAG workflow, can actually find the PDF immediately and then ask that same PDF the question that I just asked in the chat prompt here. It actually summarized it on the left, but it also highlighted, right? And Luca, on the right-hand side, the text that was used inside the PDF, where the answer came from, which is pretty neat.
So let's have a look at how this works under the hood. This is a very basic depiction of a RAG architecture. We're going to go through each and every step, but we see a few key elements: an embedding model, MongoDB Atlas, especially vector search, and an LLM. So if you remember the second demo, we were asking about adverts, weather-related accidents. And so how does this work now? So we have to vectorize the question. And this question is now used as a query for vector search. And what MongoDB does is it yields the documents that were relevant. So performing a semantic search, we get the documents that are semantically similar to the question. So as you can see in green, the semantics of the question is preserved. We had adverse weather on the left, and what we get in the documents is mentions of heavy rain.
Yeah, so just like when we uploaded an image, those images got turned into vector representation. The vectors were then passed into MongoDB. A query was executed, and a result set came back. That first demo was just vector search, no AI, right? That was just a query against the database that said, find claims like this based upon this image. This example goes one level further with RAG and says, well, that result set can then be fed into the large language model, and then the large language model can ask more complicated questions of that result set to further kind of filter and refine the results back to the user.
Questions that we don't know in advance, right?
Since you don't know in advance, and without the need to build an API, right?
So last step, obviously, is passing that information as context to the LLM. And now the LLM is able to build out an answer that incorporates that knowledge that wasn't previously known to the LLM. Okay, so again, we see the answer from the LLM, which includes mentions of rain, hail, and fire. So we see how the knowledge was incorporated, the semantics of the question was incorporated in the final answer. And this is how our RAG architecture works at a basic level. But we can do much more than that. We're having a conversation with a partner earlier, and they were showing us how they built this kind of metadata repository on top of MongoDB, where you can actually ask questions of an aggregate of what you have in your PDF. So you can ask, how many PDFs do I have? So they've been able to extract fields and information and context from those PDFs, so you can actually elaborate more holistic questions about your data set, not just about a specific PDF, but about an aggregate of files that you have.
Super duper DB. You're right next to the industry booth, one floor down in the convention hall. Super duper DB. We actually built that PDF search on Super duper DB. They've got a pretty neat product they're demonstrating in the booth.
And they finally changed their name into Super Duper. They're not called Super Duper DB anymore.
Because they're not a database.
They're not a database.
All right, so let's walk through what it looks like to architect these applications. All right, so if these are the kind of workflows that we can now transform, right, little data hotspots, how do we bring that inside of applications more quickly and more easily? Well, the actual 3 layers here of AI, we talk a lot about in the architecture world of architectural significance, what's new, what's changing, what's significant to the problem space. And so we break that down into 3 layers. First layer being, or the underlying layer being the AI models, the GPUs themselves. This is significant. We're hearing a lot about GPUs. We're hearing a lot about large language models, embedding models. Architecturally significant. Talk to me about the AI-powered apps, Luca.
Yeah, so this is what we've been showing in the demos. So now the apps can leverage AI, can incorporate it, can ask more complicated questions to the data.
Better user experience.
Better user experience.
But not a completely different agentic AI yet, right? We're just looking to actually build a little bit more lift for the business people. But the middle layer, this is really where we think the magic is. It's the tooling that gets your data into these large language models so that you can put that up into the user experience layer so you can start to make data easier to work with. How do I grab really hard to work with claim notes and claim damage photos, pass them into a large language model, and transform some user experience, make it easier for the business people to work with that data? So this is really the heart of our presentation today is really the converged AI and application data store. Luca, we built a collection in the middle, and we called it the claim collection.
Wait, this is...
yeah.
So we just wanted to unpack the architecture first. And so maybe, Jeff, you can walk them through all the different layers.
Yeah, walk us through, Luca. So this is really kind of our understanding of what's significant and what's changed about the application architecture. The tech stack you're going to see looks really similar to the tech stack that we've been building with for the last 10, 15, 20 years. A couple of nuances. Walk us through a little bit of what's here and what's different, Luca.
Yeah, so the application layer, still the same, right? What's interesting here is second layer, what Jeff was mentioning, the fact that we can kind of glue together applications and AI thanks to this layer, where we have an operational data store, where we have both structured and unstructured data in the form of vectors. And obviously that data is usually not stored into Mongo, it's just stored as metadata. So we have cloud storage where we can actually store the physical objects, right? Our PDFs, our images.
Yep. So I've always had an application, right? I've always had an application, and I've always had an application or operational data store. That application has its own database. What's different about MongoDB as your application database?
Well, a number of things, but I think in the context of this presentation, what's really relevant is how you can leverage unstructured data in the form of vectors.
Yep.
Data was previously highly hard to work with, highly inaccessible,
Yep.
unavailable.
And
to
I don't
business.
store that. That's unstructured data itself, like the raw images. I don't put that in MongoDB, do I?
You can, but that's not very smart.
Not super efficient.
I mean, there are some customers that store base64 images or PDFs into MongoDB, but that's a
No.
recipe for disaster.
I want that in
We don't
I want
advise
that in
that.
object storage, right?
Right.
I want to put that somewhere where it's easy to work with as a developer, cost efficient object storage, or maybe it's SharePoint, maybe it's a Confluence wiki, wherever that unstructured data lives. I want the vector representation of that in my operational data store so I can query my operational data and the unstructured vectors in one query, right?
Right. And then
Last but not least.
last but not least, we have the AI models and services. Our first layer, foundational models. We have our OpenAI, we have our Anthropic Cohere, embedding models, LLMs, all these kind of AI layer. And obviously the infrastructure where they run on. So hardware like such as GPUs, CPUs, and in general the cloud where they are hosted. They might not be hosted on the cloud, but that's a different story. But they need to be hosted somewhere, right? So this first layer is where they run. The infrastructure that sometimes is transparent to the user, and sometimes is because it's managed. Sometimes it's for maybe security reasons. It might be managed by the user, right?
Yep.
By the
But that's what we
enterprise.
built, right? That's the application architecture that we built. That's our tech stack. We have a user experience layer, not the prettiest user interface, certainly, but it was a UI, thin application on top of an operational data store.
Yeah, built with maybe LangChain
Yeah.
or SuperDuper.
Yep. And then inside those images themselves, we store those in an S3 bucket. And we called an AI model, right?
Right.
We called an AI embedding model and OpenAI as the large language model. And that can be Bedrock, that can be Microsoft Fabric. You can kind of plug in and plug out the different large language models. But this is really the tech stack. And you can see that it's actually not all that different from the applications that we've been building for the last 20 years. There's a couple of nuances in here, right? So let's move on and let's talk a little bit about what we think where problem meets opportunity. So this is all well and good, but half the problem is really everybody agrees. This is a Workday study from the end of last year. All the CIOs that were interviewed agree that everybody wants AI. Of course, yes. Well, what's the problem? Well, they also agreed that the data is really not very accessible, right? 4% said their data is fully accessible. So another one of those three key tenets, right? Developer acceleration, AI inside of applications, and the third one was modernization. We know that this data is stored in data stores all over the organization. If you're an insurance entity, you don't have your policies in one place. You don't have your customers in place. You don't have your underwriting submissions in one place. They're all over the place, right? So this is the problem that we think is kind of holding us back. If the tech stack is not all that complicated, it's the data layer and finding all that data and putting it in one place. So there's a few different approaches that you can take here, right? Look, I can build a relational clone. I can just take it out of my legacy database right now if it's mainframe DB2 and maybe put it into Postgres. But that really doesn't solve the problem. I can't really store vectors alongside my operational data and query them together really quickly. I can build a brand new relational model. If you have potentially multiple policy issuance systems, all of those are going to have multiple different data models. If I try to build a new relational model that can rule them all, I'm probably going to end up with kind of this Franken model, this sort of amalgamation of complexity of where I'm coming from. And that's not going to make it easy for the developers. So I might not really be unlocking the data how I really want. Or I can choose the document. I can choose the document model. You know, in Travelers, we folded 20 different policy issuance systems with 20 different legacy data models into one MongoDB collection, thanks to the flexibility of that document model. There's another major automotive insurer that has 55 different legacy policy issuance systems. They folded all of that into one MongoDB document. It's almost too good to be true, but it really is true. All of that legacy complexity, if you move away from relational, can fit into one database object under the hood. And that database object is tremendously rich And so this is sort of this is really the heart of the presentation today. If we know that we need to modernize away from the legacy silos, and we want to move to something like what Luca built, and Luca showed us in these demos, that is this data object right front and center called claim. But inside your organizations, that might come from 5, 10, 15, 55 different actual systems. I want to put all of that legacy data and conform it into one format in the middle in MongoDB. I want to fold in that unstructured data, right, Luca? I want to bring in the images and text and audio files, potentially if I have them, things that you built for us in the demo. If that is in MongoDB, I'm actually just adding more data to that MongoDB collection. So your phase one of modernization can consolidate multiple legacy systems into a brand new MongoDB document. You can then vector embed related unstructured data like claim damage photos, come back and store all of that into the same MongoDB collection as a new array. You're just kind of extending the MongoDB document. And then, well, those images have to come from somewhere. The claim damage descriptions have to come from somewhere. So you're probably going to be negotiating maybe with the data warehouse and the data lake folks, saying, hey, can I get 20 years of claim damage description history? Can I get that vector embedded? But I don't want to point my business application against the data warehouse. I want to make that vector representation easily queryable and also efficiently queryable by the business application. So I want to put that in MongoDB to make it quick and easy to access and query. So this is really the kind of culmination of, if I'm building AI into applications, that AI is probably going to want siloed operational data. It's going to want unstructured data like what Luca walked us through with the PDFs and the claim damages. And it might want damage descriptions from historical data warehouse sources. So this is really what we kind of talk about with this converged AI and application data layer. The fact that in the application space, these three types of data are going to need to come together. So Luca, walk us through, convince me why I need MongoDB for all of this. Convince me why I can't use something like Postgres.
I'll try.
Okay.
Okay, so first and foremost, the data model is probably the best way to represent data, especially in the era of AI, where we have larger and larger context windows. Just because Postgres or any relational database was not meant to be storing such large JSONs, for example. Even if we have JSONB as a format, it doesn't mean that it's going to be efficient, especially...
I got to deserialize that. If it's JSONB, I still have to deserialize that big JSON object, and I'm burning up database memory.
Right.
It's going to work good if it's maybe a couple of kilobytes, but if you're talking about large objects, that's going to get really slow.
We got to the point that we have almost 1 million token context windows, which is huge. Postgres is not going to be able to handle that.
And if it's Postgres, I'm actually executing the same API workloads against that structured data, against the regular table object, on the same memory in the same database that I'm executing all those vector workloads. If it's MongoDB, I actually can separate that out. Not only am I not doing that against the same storage engine, right? MongoDB vector search is actually a Lucene index, but I can actually asymmetrically deploy those nodes. So I can have one node of MongoDB or two nodes that are for serving the application, and I can have a few other nodes that are serving just the search workloads for that application, and then other nodes in the cluster that are serving real-time analytics. Right, so you've convinced me on the rich data structures.
You seem already pretty convinced, but well, what about performance and scale?
Need that.
Well, we briefly touched on that with the JSONB limitations, but let's talk about how MongoDB can offer a very performant and scalable architecture, and how maybe it's hard to serve the latency that is needed by LLMs with a relational system, right?
Yeah, and as these large language models, we think as the large language models themselves get more and more efficient, the GPUs are going to get more efficient for sure, but really it's the models that are going to get more and more efficient. So as the models have less and less latency, they become more viable to actually integrate into a business application where I can take some PDFs, I can take some claim damage photos, and make that easier to work with, and I'm not burning in a large amount of GPU. Mm-hmm. But I'm probably going to want to be able to feed a lot of data very quickly into a large language model. The value of the document model at the top really is not only is it a densely packed data object, I'm not talking about 50 Postgres tables. I'm talking about one document that has 50 tables worth of information in it. But that document is actually self-describing, right? The fields that are in it, there's the field names and the data for those fields. So the
Plus, you can store different vectors, right? If you want to test different models, different embedding models, for example, you can store different vectors in the same document.
So your claim example then, Luca, you picked what I think SqueezeNet was the original model.
For the photos, yeah. But I could have picked OpenAI, for example.
And you could store both. You can choose 3 or 4 different embedding models.
I can run A/B testing in parallel to pick the right model. Because I don't know if you remember Boris, what Boris said the other day, that the CTO of the Schwarz Group was saying something like, I don't know, like I'm using whatever model I'm using today. Well, one thing I'm sure it's not going to be the one I'm going to use in 18 months. So we want to stay flexible at this point, right?
But my claims are still going to be my claims. Like I'm the old guy. I know that I've got 20 years of claim history. That's not going away. I'm still going to want to work with that, even with the new business application. So in that MongoDB document, I can store an array of the vectors for the SqueezeNet representation of those images. Or maybe I decide that for some types of claims, there's another model that's more efficient at these certain types of photos. I can embed those photos and store that vector embedding, and as a different array in MongoDB, I can actually build multiple vector search indexes off of that same single MongoDB collection and use one index for one type of claim and another index for another type of claim. Maybe I have roof damage photos for property. Maybe I have car accident photos for car damages, and maybe a different large language model. One is better than the other for those different types of use cases.
And this might look like can be a problem because obviously these vectors can be heavy. But today in the keynote, they talked about quantization and how we are supporting that starting today, and that makes working with vectors much easier because they're going to be smaller, they're going to use up much less disk space.
Yep.
Okay, then, so we were just seeing how MongoDB, how it integrates with different partners, how easy it is to work with different LLMs. And we're going to see in a later slide where MongoDB fits into the ecosystem. But I think we mostly talk about this point where we're not taking like a precise stand towards a specific vendor, because at this stage, I think it's important to stay flexible. It's important to be able to integrate with everyone. So this is where we stand currently, right?
Yeah. And if I'm insurance, I'm risk averse. I'm thinking about the future. I'm not thinking about it maybe a year from now. Maybe I am, but maybe I'm also thinking about 10 years from now. I'm thinking about what's a smart, wise investment. I don't want to spend a lot of money on technology that's going to potentially go by the wayside, that is good for today. I want to make an investment that's more future-proof. And I think in this world that we live in right now, where the models are kind of in flux, the technology's in flux, the one thing that is a safe bet is that whatever those models are in the future is if you unlock your underlying data layer and you make that data easier to work with, if you put that data in MongoDB, that is a wise investment that will serve you in the future, because whatever those models end up being, you know that you've got these densely packed, rich data objects that are going to be able to be fed into those models. And if your artificial intelligence strategy changes radically 2-3 years from now, your data fundamental underlying data is probably not going to change. But if it's locked up in legacy siloed systems, you can kind of bet that that will be a hindrance to innovation and being able to leverage the innovations that do emerge. So, MongoDB AI application program. You heard from Sihir this morning. We think what that really looks like is that we're very fortunate. We're right in the middle of all of this. And if you put your data, if you put your claim data in MongoDB, if you put your policy data in MongoDB, if you put your customer data in MongoDB, even your underwriting submission data in MongoDB, you can build a single version of the truth that is transactionally performant that can now be extended with unstructured data representation, so you can start to unlock unstructured data related to policy processing, related to claim handling. And then you can take advantage of all these different partnerships that we have, obviously running on all 3 hyperscalers, AWS, Google Cloud, and Azure. But we can take advantage of all the current frameworks that are out there. Like you built these demos with LangChain, you use Llama Index,
Super duper.
Super Duper, SqueezeNet. And so this is kind of really important that you have your data fully accessible to all the kind of AI tooling and options that are out there. And so if you're looking to build solutions, Luca and I actually build these solutions with our customers, not just the demos that you saw today. That's part of the MongoDB AI applications program. We can help hit the ground running. You hit the ground running with these solutions. We can advise, we can architect, we can actually build and deploy these solutions inside your organizations. So we're coming up on the end. Luca, take us home.
Yeah, so we can see, you guys can scan the QR and you can check out the GitHub repo of the demos. You can also stop by the industry solutions booth. We can walk you through other demos from other industries. There is also a solution library page on the MongoDB website. So don't worry about missing this. It's all on mongodb.com.
So you can download these. These will take you right to the GitHub repositories, right?
Right.
Where you can download these solutions. You can run them. If you want help with them, let your MongoDB rep know or reach out to us directly or come to the industry solutions booth one floor down. We'll get your name and help you build these solutions. We can actually help deploy these particular solutions on your infrastructure if you want to use them as demonstrations for your leadership, for folks inside your organization. Can we beat them? All right, hey, folks, thank you so much. Please rate our session. There's one last QR code here. You can go to our industry homepage. Please rate our session. We really appreciate your feedback. It's in the application, the MongoDB local mobile application if you downloaded it.
The AI ebook.
The AI ebook. Come downstairs to the booth and check that out, but you can get a link to the AI ebook. Folks, thank you so much for taking time out of your schedule. Thank you so much for letting Luca and I speak with you.
We have 1 minute for Q&A.
No Q&A.
No Q&A.
Come see us after. Cheers, folks. Thank you so much.
Thank you.
Thank you.